Hello everyone, I'm Ravi and I'll be talking about Atlas. Atlas is GoJek's real-time geospatial data visualization platform. Uh, a little bit about GoJek. So we started in 2010 as a phone-based ride-hailing platform. But in course of last few years, we have evolved from a single platform to like serving 18 products, which are around food, payments, delivery, everything. So it's like the evolution has been from one product to 18 products, and then same goes for the scale as well. So today we operate in Indonesia, and we are expanding to like more South Asian markets. A little bit about me. I'm a designer, turned into a developer, turned into data journalist, then started doing visualization, and then these days I'm working on data engineering. So the agenda for today's talk is going to be, first we'll talk about what is Atlas, what exact are the reasons that we built it, and we will talk about a little bit about the architecture, and then we move on to the challenges we faced while building it. And then we'll talk about a little bit about the approaches we took while solving these particular challenges. So if you look at the GoJek, so the nature of the business we are in, figuring out real-time information and then making decisions on top of that is really crucial for us. Because a lot of things that depends on what is the demand, how's the supply, how's the conversion rate going, how's the surge is going. So all these factors depend on how the resources are behaving in the real time. And then all these resources are kind of bound to the location of the drivers, location of the customers. So everything is related to the location. And on average basis, on daily basis, we receive around 2 billion GPS data points. Okay, so what is Atlas? So Atlas is our geospatial data analysis tool. It turns maps into actionable insights. So you have certain maps with certain data points, and then it allows you to turn them into actionable insights. It supports an automated metric pipeline. So you write certain metric, and then that metric should automatically flow to the visualization layer without anyone interfering or doing any manual task around that. And then it also has a extensible visualization layer, so where anyone who's developer or even the product analyst, they can just come on and then write their own visualization layer, and that should automatically plug into the entire system. Why we built Atlas? So as I already mentioned, so making decisions in real time makes it really important for us to make sure that our demand and supply distributions is very well. So then making sense of data at such a large scale when you're receiving billions of data points, it becomes important how do you see the entire picture in a single go, right? So that was one reason that you wanna visualize that how the resource distribution looks like. And you don't wanna go through like really nasty graphs around that. You wanna have this entire look like one picture, one frame. But then if you want, you wanna deep dive into it and wanna explore more about how certain areas are behaving as well. But basically it starts from having that one picture that how the entire distributions look like. And then the distribution can be about any metric. It can be around, for example, demand, it can be around supply, it can be around any particular resource, right? And then second is that for allowing other teams to build on top of that, explore, play around with the data, you wanna have exploratory tool on which you can just explore the data, not just look at the pattern, but you can just explore and deep dive more and then do certain things with it. And then there are more reasons. So I'll just walk you, I'll just play a video which just shows Atlas in real time. Of course, it's playing like some rough data. So here is on the right side, there is a panel where you can select particular metric, and then that metric starts to display on the real time. You can pick up different metric on a different dimension. Then you can apply certain filters on top of it. And the entire thing flows in the real time. The data changes in the real time. What you're looking at is the real time pattern of the entire thing. Then you can also move around to different you can pick up different map styles. So right now these are like dummy styles, but you can have certain styles which focuses more on the roads, which focus more on the geography. based on like what exact analysis you are doing. Are you looking at like, how the distribution is according to the way roads are, how the buildings are. So depending on like specific boundaries you want to look at, you can take certain decisions. Then you can change areas. Oh, now I want to look at, let's say, a different part of the Indonesia. And then you can just move around the map and then look at that particular data in real time as well. So in a way, you have this entire picture of all the service areas which you are servicing in. And then you can just play around with that entire data exploratory. So you can look at the entire picture, then you can look at the distribution as well. Pan out, zoom in, all those things. Atlas also allows you that you can click on a certain cell and then look at the detail analysis as well. So if you want to explore a little bit more, so you can just collect one particular service area, and then you can look at the historic chart of as well, how it's playing in the real time and how it's operating. So it allows you to do the exploration as well. So let's dive deep into like what drives Atlas. So mainly there are like two foundations. One is layer, and then second is the metric. And when we talk about layers, we are talking about the layer can be choropleth, it can be point. So what were you looking at? That was an example of the choropleth layer. And then there can be routes where what you are plotting is just the entire journey of a customer from source to destination. So layers are your visual elements. Then on the other side, there are metrics. Metrics are your actual data point you want to analyze and you want to take decisions on. The examples can be demand data, supply data, conversion rate, how much conversion rate is going on. And then you can have more. So both these foundation layers kind of form the basis of the entire, how the entire platform is structured. So both these layers are kind of defined as the JSON schemas. So if you look at the schema of the layer, it defines everything that layer is built upon and how it will behave. So the entire information is captured in a JSON schema. So in this particular example, we are talking about the layer schema of the choropleth. It talks about the name, it talks about the description that you do it for doing S2 cells analysis. And then it talks about the dimension. So when we talk about the layer and its dimension, so dimensions are the endpoints on which you can plot certain data endpoint. So for example, for choropleth, 3D choropleth, you can have color distribution of any metric, and then you can have the height of the bars. You can plot one data point as well. So in this particular case, it talks about two dimensions, color and the height of the bars. If you dive deep, then it also talks about different types. What is the type of this? Is the dimension a number? Is it required? If you are plotting the entire thing, is it the required metric or not? Then it also talks about the identifier. So if choropleth and you are doing S2 analysis, that is also make sure that layer definition should have, the metric definition should have that particular data endpoint as well, which is S2 ID in this particular case. Similarly for elevation, if you look at the height of the bars, it talks about type, required or not. Similarly, the entire metric is also defined as a JSON schema. So in metric schema, again the same thing. You can look at the name, it talks about the description. It talks about the frequency. We will deep dive more into like what exactly this frequency means. It talks about status. So when you have like 10, 15 metrics flowing in the real time, then one of the metric goes down, one of the backend system goes down, which was driving that particular metric. So you want to display to this user, to your users, that right now we are not serving this particular metric, or there's something wrong. So it's talk about its status as well. Then it talks about its scale, that how you want to plot it on the map. It talks about the tags. Tags are basically your, like on the visualization layer, when you are exploring the entire thing, what all filters you can apply. So you can apply a filter of the service type, or you can apply a filter of the S2 ID. Then it talks about the data points, which are fields. Then fields can be your, like if it's a demand, then it can be unique customers in a certain area. And similarly if you're having different metrics, so these things will change. But the point is that you can have the layer and the metric defined as a JSON schema, and anyone can just write a new JSON schema or the new layer and then just feed into the entire system. Now how these schemas kind of map into an interface. So what you're looking at is the interface for where you exactly mapping people who are using end consumers of the platform. They map up, they pick up certain visualization layer. They start with the visualization layer that you wanna visualize on heat map. You wanna look at the data clusters, or you wanna look at the choropleths, or you wanna do something else. So you can just pick a layer, and then based on that layer, based on the schemas we define, We do a simple matchmaking in terms of, okay, this particular layer is supporting these data points, so you can just display these particular metrics in there. So as soon as you select a layer, it automatically filters down the certain metrics you can display on the platform. And then once you select that, you can pick up which particular, what all those filters does this particular metric support. So it boils down to the same thing. You pick up the upper layer visualization, then you pick up the metric, and then based on that metric, you pick up a certain filter, and then you can just look at the time span as well. So you want to go history, you're going to look at the real time, you want to pose the entire map. So just a bunch of things you can do around it. Then once you have that entire frame displayed, then you can click on that one particular frame, and so each cell, when you are defining the schema of it, it can also tag to the information panel, which is like just one interface on the side. And then it can tell you, okay, once I am there, then I can give this particular information, and then you just need to display it. So each layer can then also talk about, each metric can also talk about, each layer will talk about how it will display that particular information once you click on the exploratory part. And each metric will tell about what all information you can give to that particular layer. So then you can give any stats around history you can give of the map and the other stats. Then they talk about that, okay, based on certain area, certain analysis you want to do, you can build your own maps which kind of focus on the roads or the boundaries or different sections, and then you can plug them into the system as well. Okay, so now let's talk about how the metric pipeline happens. So when you have 15 plus teams and you are supporting with them, all of these teams with a single platform, how do you make sure that people can analyze and visualize these metrics in real time without any development effort? How does the entire data flow system will look like if you don't want people to put any development effort, but you still want them to capture this data and visualize and explore in the real time? So this is how the overview of the entire architecture looks like. So first we have the data streams. So data streams are just mainly like Kafka clusters, which has the raw data coming in from different ingestion pipelines. And in data streams right now, we are receiving around 6 billion plus events, out of which 2 billion are around location, which is we are targeting in this particular case. So this is the data stream. Then we have another layer, which is the data aggregation layer. So what happens in data aggregation layer is that we have built certain tools on top of the Flink. So at the core, there is Flink, which is doing real-time aggregation. But we have a Atlantis interface, which is a SQL DIY interface, custom built by us. This particular interface is targeted towards the user who are like product managers, business analysts. So they just go to the platform, write certain SQL queries, and then just submit that particular job. No end consumer is involved in this. No one else, no one from data engineering team is involved in this. Anyone who wants to look at certain data, they just go there, product manager, the business analyst, and then they just enter a simple query. And once you write certain query with the Atlantis, this goes to the Dagger as the Flink as a job, and then the Flink starts pushing that data into a time series database. At the same time, as soon as any of the business analyst or the product managers, any of the user who's writing these queries, submit that particular job, it also goes to a system called Cosmos. I'll talk about that in detail. Why it goes into Cosmos is just to make sure that to Atlas, it registers that, okay, now you can start listening to this particular metric. Someone has registered this metric into the entire system. Then is the data visualization layer, in which we have 3 services. One is Enigma, written in Go. We have service Cosmos, written in Node.js, and then that Atlas platform, which is written on React with the D3 and then built on top of DeckGL. So Enigma reads from the database, and it gives a simple interface for anyone to query the time series database. It provides a very flexible API in which you can just you can access. Okay, I want this particular metric, this with these filters, just like pretty flexible enough. Then Enigma also deals with the user census, in which if there are like 100 users who are using the platform right now, how many metrics they are registered to, who all are listening to which particular timeline. And then it just makes sure that, okay, that user census is built and it takes decision based. We'll talk about how this works in a bit as And then we have a system called Cosmos. Cosmos is the place which holds the metric definition. So whenever user submits certain query onto the Flink, it also calls Cosmos, just telling, okay, now I'm registering this particular metric, so you can start listening to it. So it holds the entire metric definitions, and it holds the user configuration of how many users are kind of subscribed to these particular metrics or these particular visualization layers, and they're interested into these things. Then finally, we have the Atlas, which is the user interface platform, which is the visualization platform in itself. And Atlas also holds the layer definitions as well. Layer definition in which we talked about our choroplasts, heat maps, and all. So this is how the entire systems look like. So with this, what happens is that you have the entire flow going on, and people like product managers and business analysts, they are writing the certain queries, but the end consumer is never involved into any development effort. But it also but this system, the way data flows, it makes sure that anyone registers a certain metric, it reaches the end user. So people are now able to visualize this data in the real time. But what is real time? So when you have different metrics, and these metrics have different behaviors, what exactly the real time means, and how does it affect the entire performance? So we'll talk about two main aspects. One is that performance, and another is the synchronization part. So let's talk a little bit about the metric frequency. This is just a simplified view of two of the metrics, but it can be complicated based on the sliding window as well. So what is happening in here is that you have demand and you have supply. These are two different metrics. Now, there can be different pattern in which you want to aggregate that particular metric. So in supply, you are receiving all the drivers sending you location data. But you want to aggregate it over 1 minute and call, okay, this is my average supply over last minute, or you want to aggregate over, let's say, 5 minutes or 10 minutes, like that. So depending on how you do the aggregation, which in our case are the product managers and business analysts which are defining that. So it can change for any user. And then similarly, it can vary for different metrics. So it depends on the metric itself, and also it depends on who's writing those queries. So the system now need to make sure that doesn't matter who's writing these queries at what aggregation window, and if this window is just a static window or it's a rolling window, the Atlas and the entire platform has to make sure that it can adapt to that and utilize that. So this is how so for example, in this particular case, what you are looking at is that demand is getting aggregated over 60 seconds, but supply is getting aggregated over 90 seconds. So real time for these particular metrics, now demand becomes 60-second window if you're not doing a rolling window. So now this metric will come to you in real time, but the real time is at the gap of 60 seconds, and for supply it's at the gap of 90 seconds. So the way we solve this problem is that in metric you look at the frequency. So this frequency, so anyone who's write that particular aggregation query, it's also defining what is the frequency of that particular metric, and in this particular case you are looking at the 60,000 milliseconds. So how do we go about that after that? Okay, so based on that frequency, this is how the flow of the data looks like, so that you don't affect the performance based on that. Because if there is a certain metric which is doing aggregation, let's say 20 minutes, you don't want to pull the real-time data for that particular metric every 10 seconds, because it's not going to change if you're not doing rolling. So you got to make sure that anyone who writes certain metric, you does not make an unnecessary call from your visualization platform. So the way we solved it is that this is how the entire flow looks like. There is client A subscribing to metric X from the Atlas, and then Cosmos registered, okay, for this particular metrics, aggregation frequency is these many seconds. So it starts polling Enigma based on that. So the connection between Atlas to Cosmos is socket, but between Cosmos and Enigma, it's HTTP long polling. So client A is subscribing to metric X. So in user senses now, one user is accessing metric X at some aggregation frequency. Now, and again, then that client starts to subscribe to metric X. And then it's, okay, let's assume that the client subscribes to metric Y. Now, Cosmos will check, okay, if that metric Y is already subscribed, if it's already subscribed at that particular aggregation frequency, it will start serving the same user with the same frequency. So he's not going to register another call to the Enigma to do continuous polling of that particular data. So it takes decision based on if that particular metric is already subscribed and is it subscribed at the same aggregation window. Similarly, if client Y comes and asks for the same metric at the same aggregation, it knows that I have a census where I'm already subscribed to this particular metric for this particular aggregation, so it's not going to make a call. But if another client comes and asks for a different metric with a different aggregation, it makes sure that, okay, now I can register to this particular metric at a different frequency, so I'll just make those many calls. So if the metric is doing aggregation at 2-minute level or a 10-minute level, it's not going to make call every 10 seconds. It knows that when I have to make the call. And then Cosmos and Atlas is a socket open connection, so it delivers to the Atlas at the same time. So this way, doesn't matter how, who's writing one particular query and what aggregation they write onto, the performance of the entire system will not get affected because it will start making calls based on that only. The second is metric delay. So now one aspect we talk about is how you are doing aggregation. But then certain metrics also have a behavior of you cannot really define them until a certain point. For example, supply or the demand, these are like real-time metrics. How many customers are present in certain area defined and they are requesting for a ride defines your demand. So this can get as real-time as you want. Like in a fraction of a second also you can define, okay, this is my current demand, right? But for certain things like conversion rate, so conversion rate defines like how many rides you are converting from success. So in that particular case, you can't really calculate conversion rate till a certain point of time. For example, maybe like the ride is not completed, so you cannot accurately calculate the conversion rate. Definitely it depends on like how business analysts and the product managers are defining that particular definition of conversion rate. But it's still, for certain metrics, you cannot really calculate them until certain events happen, and that event is going to happen in near future. So now you have to wait for that particular metric for it to calculate. So now the real time again becomes, okay, when exactly this real time will happen. So now it's real time metric, but this real time metric has a future aspect of it. You will only be able to calculate in the future. So if you are calculating in the future, then you are putting a delay into that. So conversion rate, if you are saying it's lagging behind 15 minutes. So it's as real time as it can get, but it's still in the exact time frame, it's 15 minutes behind the entire system. But demand can be, let's say 1 minute, or supply can be 5 minutes, or you want to do it 1 second, then it can be 1 second. So now the metrics have a delay factor, like certain metrics can vary in time. Okay, so in metric schema, we also had another field which talk about delay as well. So whenever you're registering your metric, you tell about the delay as well. So this particular metric is going to have 20 minutes delay. Sorry. So now each metric is having different delays. So different metrics have different aggregation happening at different timelines. Now someone wants to explore this data and they want to say, let's say I want to compare the demand with the conversion rate right now. I want to see if there is a change in the demand, how my conversion rate is getting affected. If there is a change in supply, how my conversion rate is affecting. But what you are looking at the demand at the right now. But you are looking at the conversion rate which was calculated 15 minutes back. Both are as real time as they can get, but there is a difference in the time frame you are looking at it. So how do you deal about that? Because different people will write the queries which has certain delays, and we as a platform don't control that. So you want to make sure that your platform also handles that part depending on how much delay that particular metric is serving. So there is no silver bullet for that. So the approach we followed is that we gave users a choice. Okay, so I'm mapping on color, I'm mapping one particular metric, and on elevation, I'm mapping another metric. So user has this choice of picking which particular metric they want to map. So based on that particular metric, you calculate, okay, these individual metrics have these many delays. Demand has, let's say, 1 minute delay, but conversion rate has 15-minute delay. So now we give user a choice, okay, that you want to look into which particular time frame. You don't care about it and you just want to make sure that just display as real time as they get to me, or synchronize it to the earliest time frame, which is 15 minutes for both of them. So in that particular case, what we do is that we pull the demand data 15 minutes behind the latest of the demand calculation. For conversion rate, we pull it the latest of its calculation. So you can take the earliest approach of this, so you can bring different metrics into the synchronization frame. Or if user doesn't care about it and taking independent decision on both the metrics, so you can serve them as latest as they want. So this is how we approach the metric delays. Now all this is good. So you build, as a data engineers, we built a nice tool which is flexible enough. You don't have to do any development effort. And you can explore the entire data. You can explore the visualization. You can take certain decisions on top of it. So you have so many features and you have a nice tool at the end. But does that really solve the problem? I don't think so. It doesn't. So we build this tool and we started rolling out to the people. So the problem we start to face is the user adoption. And we have rolled out it to a couple of teams, but even today, this is a continuous problem, that how do you make sure that whatever traditional ways people were doing, taking certain decisions, how do you change that particular behavior? Then it also comes to like how you make sure that your user adopt to that particular feature. So just the key takeaway into like this particular part is that whenever you are building a certain tool, just also make sure that you don't entirely look at it from the technology point of view. You also make sure that you look at the customers and then how the new tool you are bringing is going to change their behaviors. So this is like another key takeaway in this particular case is that in starting we faced a lot of issues in terms of making sure that people in the org are utilizing the platform to do certain things the way we want them to do. But that was not exactly the case we found, and then this is the problem still we are facing, but it's an ongoing process. Cool, so that was it. Open to questions.
Hi Ravi, so
Hey.
This is Hussain. I just wanted to ask, what was the existing solution that was existing at GoJek before you started building this tool, and why did you go with the build versus buy? Why did you go for a build decision versus a buy decision?
Why do you think I?
So you took a decision to build it in-house versus buying a tool that is out there. Why
Sure.
did you go for a build versus buy decision?
Sure. What existing tools we were using? So we were using a lot of visualization tool, including Grafana, and doing like all the current existing visualization tools. The problem we faced is that so we had a certain aggregation pipelines where users are driving this. So when you look at the other tools around that particular phase, that you start to realize, okay, these tools are not providing you flexible. These tools are not flexible enough to adapt to these particular certain cases. So we couldn't find any tool which can deal with the delays. We couldn't find any tool which can look at the entire frame, but can handle with the frequency as well. So then you start to face different issues. So, and then the way you wanna present it to user, that experience doesn't come into the picture. So that was the motivation that we end up building the entire tool in-house. But yes, earlier we were looking at the traditional like different visualization tool like Grafana and all those things.
Ravi, one quick question on the query. So you had a Data Atlantis interface to go ahead and allow business users to write their own queries.
Yeah.
So my question is, once they wrote the queries, did you kind of materialize a pipeline specifically for each set of queries? And related to that question, so let us say a business user wrote a query for visualization, and that was very similar to which someone else has written. So do you kind of
when you say somebody else has written,
so same kind of visualization, so same kind of business query was written by two business users.
Sure.
So do you kind of link them both or create a separate pipeline for each of them?
Sure. So the way we are dealing with this right now is that once a certain user write a certain query, we have some metadata associated with it, which talks about what is this metric is going to talk about, why we are visualizing this, why we are analyzing this. And then there is a central place where all these queries written by different people are listed down. So right now we are not doing any background check into that because the set of the people who write these queries is not really big, and then they communicate with each other quite frequently. But so right now it's just that we are listing down the entire thing, and people just look at it if someone has already written a certain query like that or not. But yes, once the scale will grow and when you have certain more users, then we will definitely take the measures where internally you are checking if this query is operating on the same parameters, which if there is a... Yes, there is individual pipeline for each metric. So there are like certain jobs scheduled behind the scene for that metric, and these all are running independently. Sorry for? Yes. Yes.
Next question. Hi Ravi, it's
Hey.
a nice talk. Can you put some more insight into timeline synchronization? What is the mechanism underlying it?
Sorry, what is the?
Timelines synchronization.
Yes.
What is the mechanism underlying it? How it is done basically?
Yes. Okay. So as I communicated in the talk a little bit, so what happens in the timeline is that in terms of synchronizing different data, you can't really make sure what is user want, right? It's the user specific need, and it can vary based on different users. So on a system behind the scene, we cannot take an implicit decision on how you wanna look at which timeline you wanna look at. You wanna synchronize them to the earliest point, or you wanna synchronize them to the latest point. So what we are doing right now is that we are giving this option to the users that there are these 2-3 ways. Either you can look at as late as you want, you can synchronize them to the latest of that one of the metric, or you can subscribe to the earliest of the metric. So right now we are giving users these 3 choices, and based on that, they take the decision on their own. So we are leaving it up to the user. Another way you can approach is that the business analyst who's writing those queries can define this metric is best synchronized with this way. But then again, you're gonna have a problem where if you have different people who are writing these different queries, but at the end of the day, you are not controlling how user is gonna pick one metric or another metric. And if you have 100 of metrics going through, then you can never really make sure that how you will do synchronization behind the scene without asking the user. So we found that it's best to just give certain options like earliest, now, or the latest, and then just let user decide that for them what makes more sense.
Question from the back row.
Ravi, over here.
Yeah.
Hi, on the left towards the
Yes, got it.
left. So Uber has a similar tool called Kepler.gl, also built on deck.gl.
Yes.
In terms of choice between using Uber's solution and building your own,
Yes,
how
sure.
did you make that decision?
Sure. So behind the scene, we are using deck.gl, which is open source by Uber. But Kepler.gl, I think, came just like 2 months back, and we have been using this tool, maybe it's been like more than 8 months now. But yes, I mean, definitely maybe Kepler was already out there at that time, so maybe wouldn't have gone through the whole process and plugged into this, which we did for the deck.gl. Deck.gl was an open source library, so we are utilizing that under the hood. But yes, we built the tool way before the Kepler, so couldn't choose.
Hey, hi Ravi. Hey.
Hey.
So basically, as you said, any product manager or a business analyst can write a query.
Yes.
So it will be a long-running query, right?
Yes.
So how you are planning the resources, how you are managing the resources, and the windows can be long, like day or more than that.
Sure. So the way we are happening is that behind the scene, what is happening is that all these queries kind of run on the Flink. So the aggregation happen in the Flink jobs, and under the hood we are using Yarn for now. I mean, it's a combination of like for certain things we are using Yarn, certain things we are running the Flink jobs on the Kubernetes as well. So then the resource management and the job management is completely done by the Yarn or the Kubernetes, which are like Flink jobs at the
So like if it is a long-running query, so then executors like keep on submitting every query.
Yeah. So with Flink, Flink takes care of all those things under the hood, right? So even if it's a long-running query and long aggregation, it keeps on doing aggregation in the real time. So that's how the architecture is. These all queries are supposed to be long-running, in which you are doing aggregation in the real time. So the entire architecture of the Flink is like that, which we are utilizing under the hood.
Any more questions? We can still take 2 questions. We have time.
Cool. Thank you, guys.